Booleans are special case variables in the sense that they hold just true or false values. By itself, you might not use Boolean variables or actually declare Boolean variables like you would when you use data types such as strings or list objects. But Booleans are what we will use to control the flow of our program or identify when to exit a loop. And rather than declaring Boolean values, we often use various expressions such as 1 greater than 2 or A greater than B. Or methods like did we find a value X in our list to control these methods will return us true or false values, and then we'll use that to control the flow of our program. So in Python, Booleans are declared, or Booleans are true or false keywords. So A is equal to true, which is a Boolean, or B is equal to false. Note the capital T and the capital F. If you declare a lowercase value such as X is equal to true, this will throw us an error because the lowercase true in Python doesn't hold a special meaning, and it actually expects to have a variable by the name of true. And you can check the type of a variable, whether it's a Boolean or not, by using the type function that's built in. And see, if I say type of A, it will tell me what type of a variable this is, and bool, short for Boolean, will be returned. If we're checking using expressions to return values, so if I said 1 greater than 2, that will say false. That we'll use an expression of such to say if A greater than B, then do something else, do something else, right? So that's a true and false statement there. Or if you wanted to compare to values or compare to strings, you use a double equal sign instead of a single equal sign here, which we use for assignment, and for comparison of equality we often use a double equal sign. So this returns true, that's saying 1 is equal to 1. We also have a special value called none in Python. It's similar to a null value would be in C or Java, right? More often you would use that to create a placeholder that for a variable that you could use it later. So if I said C equals none, that's a placeholder that I can use, as opposed to if I were to not do something like this or provide some other value for C or any variable for that matter, and use that variable later on in the program without declaring it, then you get an error. So for example, if I were to say X is equal to D, right, assuming D was declared somewhere up into my program, it would actually throw an error message saying that D is not defined because, well, we never declared or created that variable D. But if I said D is equal to none, and now if I said X is equal to D, that works because D was defined earlier on somewhere. And we've also seen this this none type when we talked about dictionaries. So we can use the none variable or none value to interpret an absence of something, or interpret it as something being not true, right? So if we had declared our dictionary D and said A is equal to 1, right, just a short thing, and if I said d.get and I called for B, I get nothing, right? Essentially I did get something. If I did the same thing again, I said B, it actually returns a none value, which says so you could interpret that as a way of saying an absence of a value, or as something being not true. Now, while we're on the case of special values and variables in Python, we also have another data type called sets, and we haven't talked about sets earlier on, but it's just a recent addition to Python. I think since version 2.4, if I'm not wrong. And in essence, sets are unordered collection of unique immutable objects. So 2 keywords here is they are unique. All the items in the sets are unique, and that the sets are immutable, so similar to what strings and numbers are, right? And we can use all sorts of set operators and functions to perform various values. And to declare a set, we would say we would use the keyword or a function called set, and I can call 1, 2, 3, or pass in, actually it's sets. Sorry, I have to pass in a list here, not multiple values, right? So this creates sets takes in a object and in the sense a list or a string or a single number, and then converts it into a set and stores it into a variable. Or we can also use curly braces like we did for dictionaries here, except for key value pairs you just pass in variables, right? So if I say s, that's a set, or sorry, lowercase, well, caps lock on, lowercase s, right? It's a set of 3 items, A, B, C, or 1, 2, 3. And I can also say, let's call it P is equal to, and a set of A, B, C, right? So if I call P, it's again a set of 3 items, A, B, and C. We can also use the ampersand operator or a pipe for union, ampersand for intersection, and a minus operator or the minus sign to find the differences between the set. So let's take a look at a quick example of that, right? So if I said x is equal to, well, let's clear this out real quick. I said x is equal to set, or I want to declare it this way. Say h, a, m, y is equal to, what do I have? M, a, and p, and z is equal to, let's use the set function here, and we're going to call this, whoops, forgot to complete this, c, a, and n, or m, right? Well, I'll just call it n. Okay, so now we have 3 sets, x, y, and z. And if we wanted to find an intersection of the two, we would use the ampersand operator. So x ampersand y returns the intersection or the common elements between the two sets. Union x pipe, well, this is a pipe character, which is shift backslash, I think, and that would generate all unique elements between the two sets into a single new set. You can say x minus y, that gives you just the difference between the two sets. And you can also actually compare, I think, the two sets using the comparison operator of greater than or less than to say whether or not the two sets are equivalent or not. Now notice I did say that sets are unordered list and unique list, or unordered unique objects. So when we said x is HAM, when we defined when we printed x, our set x, the order of elements was not the same as the one that we added. So similar to what a dictionary was. Also, it is unique in the sense that, or the sets are elements in the set are unique. So when we said x intersection or x union y, we did not get multiple copies of A because A is available in x and y, right? So in that sense, I really like to use sets as a quick way to filter through a list, for example. So if I were to, for example, if I read in 2 sets of gene IDs from 2 different sources, and then I want to quickly find out a unique set of genes, I could use sets to do that. or set of common genes between the two data sets. I can do that as well using sets instead of having to write various iterators and for loops to run through both lists one item at a time and then compare them and create another list or another object that holds those unique values. So in that case, sets are a great quick way of doing the filtration for your list that you have.